Okay, so this lesson we're going to be looking at power and then extending it to look at efficiency. But really these are terms very much associated with work and energy that we looked at previously. So last week we looked at energy, and when we do a certain amount of work we use a certain amount of energy, and the unit that we use for energy is the joule. So we're going to imagine we've got some little lumps of energy. Obviously energy doesn't usually hang around in little lumps, but let's just imagine here that we've got 5 little lumps of 10 joules of energy. We've got a total amount of energy 50 joules, and this energy is being used by a filament lamp. Okay. Now we've got another group of energy, 10 joules a pop, and this energy is going to be used by our energy saving lamp. Okay, quite clearly an energy saving light bulb here. Okay. Now we know that if we leave a bulb on for a certain amount of time, a filament lamp, it's going to use all 50 joules of this energy. And if we leave this bulb on for a certain amount of time, the energy saving bulb is going to use 50 joules of energy. But that doesn't really help us judge the merits of this bulb against this bulb. So what we really want to know is how quickly it's using this energy. So we need a sort of element of time in here. Now we should know, hopefully, that this bulb here, the filament lamp, tends to use more energy in a certain amount of time than this lamp here. So let's try and put a measure to that. Let's think, what if this bulb here used all 50 joules of that energy in 1 second? We could then say it has a certain amount of power, i.e. it is transferring a certain amount of energy in a certain amount of time. And so an appropriate way of saying this might be that its power is 50 joules per second. Now this one here, we think it's going to use less in a certain amount of time, so what if it used just 10 joules in a second? So in total it might use all of this energy, but in each second it's only using 10 joules. So how much energy it's using per second is its power here, 10 joules per second. Now this leads us to firstly a definition of power, which is the energy transferred by a device divided by the time. Okay, so that's a general equation of power. But obviously we need to define the units here, and there is a special unit for power. And the power unit we usually use is the watt. So power in watts, you probably will have seen that written on light bulbs, like a 60 watt light bulb, 80 watt light bulb, is the amount of energy transferred in 1 second, or rather, if you take the amount of energy transferred and you divide it by the amount of seconds of time, then you have the wattage. So i.e. 1 watt is 1 joule per second. So going back to our previous example, that would give us a power for the filament lamp of 50 watts, and it would give our power for the energy saving lamp as 10 watts. So we now have an idea of which one is going to use more energy in a certain amount of time. But really we're interested not only in that, but how much of that energy is being used usefully, how much of it is coming out as light. It might be that this is just a brighter bulb, so obviously it's going to use more energy, or is it that one is more efficient than the other? So we're going to look at what we mean by efficiency. Firstly, let's consider the two bulbs again. So this bulb here has electrical energy coming in, and it's going to have a certain amount of light coming out and a certain amount of heat coming out. heat is always going to be the wasted energy. And that's exactly the same for our energy saving lamp. We're going to have a certain amount, sorry, slightly scrappier drawing. We're going to have a certain amount of electricity coming in, and again we're going to have light and heat coming out. Okay, and we're going to try and use the same amount of energy that we had before. So say we put in 50 joules of energy in total to this one over a certain amount of time, and out of that 50 joules of energy, say 10 joules ended up being light and 40 joules ended up being heat. And in this one we put our 50 joules of energy in, and then 40 joules came out as light and 10 joules came out as heat. Now it's obvious to us from this example that this bulb here, the energy saving bulb, has used the energy much more efficiently, i.e. more of what we put in has been transferred to a useful format. But we need to put a measure to it. And to help us think about the measure, let's use a very simple analogy. If I'm playing basketball and I take 10 shots at the basketball net and only 5 of them go in, I might use as my measure for efficiency a percentage. I might say out of the 5 shots I got 50% of them in, and to do that calculation I would do the amount of useful shots divided by the total amount of shots that I took, and that would give my sort of decimal percentage, 50%. Obviously to get an actual percentage I would times it by 100 to give my 50%. And that's exactly the same with energy. We divide the useful energy by the total amount of energy we put in, and we get a measure of electrical efficiency, or just energy efficiency. So our final equation is efficiency as a percentage is equal to the useful energy divided by the total energy supplied times by 100 if you wanted to get it into percentage. Okay, we don't need our equals there. So for this example here, for instance, we'd have 10 divided by 50, so we'd have 20% efficiency. Here we'd have 40 divided by 50, 0.8, so we'd have 80% efficiency. Now it doesn't actually matter whether we use joules or power, watts. We could have done the same example with the wattages from the previous page. So we could have said out of 50 watts, 10 watts is produced as light, 40 watts is produced as heat. Here we could have said 10 watts of electrical energy is supplied, and out of that 8 of them come out, 8 watts come out as light, and 2 watts come out as heat. It doesn't matter, because when we do it with energy we're considering in a certain amount of time. With watts we're just saying in a second 50 joules will go in and a certain percentage will be used as light, a certain percentage will be used as heat.